Okay, so in this example, what we want to do is we want to find the equation of a plane that passes through a point and contains these two lines of intersection. Now there are multiple ways to do this problem, but I'm going to do it just the way that that I'm going to do it here. Okay. So what's the first thing that would be very helpful? That would be very helpful to have.
Diagramming out the intersection of the two planes.
That's right. That's right. That's right. And incidentally, this point here, we can show that this point is not on either of the planes. Okay, so if we go to the next page here, we know the intersection of these two non-parallel planes is a line L. And we note that the point -1, 2, 1 does not satisfy either equation of the plane. So this point's not on the line L. So this here is a legitimate diagram that I have. Okay, legitimate diagram. Okay. Okay. And what we want to do is we want to find two other points on the plane. Okay. And actually, this problem here, well, yeah, we want to find two other points on the plane. So what I'm going to do is I'm going to let x equals 0. Okay, so now again, there's another way to do this problem, but I just want to do it this way because it's just a way to do it. Okay. I have two planes. The planes intersect in a line. The line is not going to be the line is going to be definitely a skew line. So at some point on that skew line, the line will pass through a point whose x-coordinate is 0. So if I put x equals 0 in both of the equations of the plane, okay, I end up with a system of two equations and two unknowns. Okay, and no, I end up with a system, of two equations and two unknowns, and I can solve for y and z. I find that z equals 3/2, and so y equals 7/2, and so the point 0, 7/2, 3/2 is on the plane. Okay, so that point Q, for instance, could be this point. Okay.
Did you say that this point Q is both on line L and therefore on both planes?
The problem, this line L in the picture above, okay, this line L here is the line of intersection of the two planes. Okay, this line L is the line of intersection of the two planes. We want the plane that contains the point -1, 2, 1 this point here, and contains this line of intersection. So if I can find 2 points on the line of intersection, then what I'm going to do, right, is I'm going to find the vectors. So like for instance, I found Q. I'm going to find another point R next. And then what I'm going to do, right, what I'm going to do is I'm going to find vectors PQ and vectors PR. And then I'll take the cross product of those vectors so that I can get a normal vector to the plane. That's the strategy here. That's the strategy. So my normal vector to the plane would be equal to the vector PQ crossed with the vector PR. Hyunwoo, does that make sense? Good. Good. All right. So, all right, we found one point Q on the line. I want to find my point R on that line of intersection. So what do you recommend I do? I have some freedom here to do things. To get the first point, I let x equal 0. LES, how do we know -1, 2, 1 is on the plane? You are, hold on here. You are told that the plane passes through the point -1, 2, 1. Yep, that's right. That's in the example that you copied. It's there. It's there. Good question. Okay, so how do you suggest I find this point R? That's right. How do we find the point R? I got to do something to find it.
Not used any parametric functions just because we're not dealing with that.
Well, look at what we did here to get the point Q. We let x equal 0 because that line L, that line of intersection L, that skew line, at some point there'll be one of the points on the line will have an x coordinate of 0. I suppose another point on the line might have a y coordinate equals 0. That's right, Andrew. So that's what I'm going to do. I'm going to now let y equal 0, substitute y equals 0 in the equations of the equations of the plane, and I'm going to solve. I'm going to solve for x and z. And when I do that, I'll get x equals 7/5 and z will equal -3/5. So yeah, they're fractions. They're not pretty, but that's okay. I found my point R. The point R is 7/5, 0, and -3/5. Are there any questions so far? After this problem, we'll definitely take our break, but All right. May I move to the next page? Maybe give me a thumbs up if you're ready to go to the next page. Okay, excellent. Right. Okay. So, very good. So, here's that picture. Here's that picture again. But hold up. Hold up. Yes, the normal vector is the cross product of PQ and PR. But that's going to involve some ugly fractions, right? What if I found a vector parallel to PQ? So the PQ vector is and you notice I'm doing it the easy way here because I drew a picture. So it's good to draw a picture, right? Yeah, the vector PQ has components 1, 3/2, 3/2, and a half. And the vector PR has components 12/5, -2, and -8/5. But I got fractions in there. Maybe I can, if I were to find parallel vectors to PQ, if I were to find a parallel vector to PQ, say the vector 2, 3, 1, because 2, 3, 1 is just, if you take the vector PQ, well, how am I getting 2, 3, 1 from the vector PQ? Right, it's a multiple of 2. It's parallel, 2, 3, 1. That vector 2 with components 2, 3, 1 is parallel to my vector PQ. And similarly, the vector 12, -10, -8 is parallel to my vector PR. It's parallel to my vector PR. Okay, but because that's, well, 12, -10, -8 is what multiple of PR? Twelve, -10, -8 is
A 5 constant multiple of PR.
That's right. That's right. Good on you. But still, I'm not happy enough with that. 12, -10, -8 happens to be parallel to the vector 6, -5, -4. Okay. Okay. So all right. So is let me just see here. I think I'll write it with my stylus. Is PQ, hold on. Is PQ cross PR parallel to 2, 3, 1 crossed with 6, -5, -4? It is. So in other words, let me just rephrase it here. I like things to show nicely because there's going to be a recording here, right? Let me just show it again. Sometimes PQ cross with PR is parallel to the cross product of 2, 3, 1 with 6, -5, -4. And incidentally, the cross product of PQ and PR is that normal vector. So the normal vector then is parallel to this cross product vector, to this cross product of those two vectors. And that's the point is that the cross product of these two vectors is perpendicular to the plane. And that's all we need. That's all we need. Because the cross product of those two vectors, 2, 3, 1, and 6, -5, -4, the cross product of those two vectors is parallel to the normal vector. The normal vector is perpendicular to the plane, so the cross product of these two vectors is perpendicular to the plane. And so I'll go to the next page here, and I have something I gotta correct here. Something I gotta correct. This is not right, PQ cross PR that I have here. Okay, this is the 2, 3, 1 crossed with 6. I still don't have enough room. Doggone it. I'm going to do this right, class. I'm going to do this right. I'm going to do this right. I just have to write a little smaller. That's all. Try it again. All right, what do we got here? We have 2, 3, 1 crossed with 6, -5, and 4. That equals what we have here. All right. Are there any questions on that? I like to make sure everything is clear and logical. You know, we have to be clear and logical in multivariable calculus. Okay, so we end up getting then -7, I mean the cross product of those two vectors is -7i plus 14j minus 28k. But if you don't mind, I will say that that is parallel to the vector -1, 2, -4. And I will use that vector. I will use the components of that vector as my A, B, and C for my equation of the plane. And then the point that I chose, the 3 points, naturally I chose the -1, the 2, and the 1 to be my point on the plane. And I work it out, we work it out, and we get our answer. Okay, are there any questions on that? Ian, it would be correct if you didn't reduce it. I think WebAssign would accept the answer unless they said reduce your numbers. It would still be correct. Yes. In other words, Ian's saying that if you use the -7 and the 14 and the -28 and to find as your components, yes, the equation of the plane would be equivalent. That's correct. Very good question. Are there any other good questions? Okay, let me stop the recording.